Hello, ladies and gentlemen. This is Mr. Green again, and this is another one in the series of pre-cal recordings that I'm making for you so that you can do the problems in the class, so to speak. So let's look at this. We're going to try to apply some quadratic functions today. We're going to look at some applications of how quadratic equations are applied in a real world setting. This is not just for the sake of doing math, guys. This is real world stuff. We have to use these things all the time, okay? So there's a river cruise. A 3 hour river cruise. 3 hour cruise. Okay, wait a second. I reverted into something else. Squirrel. Okay, yeah, I'm back. 3 hour cruise. 15 kilometers upstream and then back again. The river has a current, that means the speed the river flows, of 2 kilometers an hour. What's the boat speed and how long was it was the upstream journey? Well, they know they're going to go 15 miles upstream, right? And they know that the speed of the river is 2 kilometers an hour. You know what? I like to look at this a little bit graphically. So here we got a boat. See my little boat here? And it's going to go 15 kilometers upstream and it's going to come back downstream. And it's going to take them 3 hours to do this. Okay? And we know the river is flowing at 2 kilometers an hour. So there are two speeds that we have to worry about here. We have the speed of the boat going up and the speed of the boat coming back. But in actuality, it's just one speed. If you look at the speed on the land, if the boat were on the land, it wouldn't have that river that it has to fight going upstream, right? It would have just one speed. And so what you can do is you can represent the speed of the boat as x minus 2 going upstream and x plus 2 coming back downstream. Those are the two speeds that the boat is traveling at, one upstream, one downstream. You can turn these speeds into times by using the concept of time is equal to distance divided by speed. So if we want to know how long it's taking them, they're going to travel at 8 kilometers. If you travel at 8 kilometers and 4 miles per hour, it would take you 2 hours to get there, right? So we know that formula works. We can use that formula. And how are we going to use that formula? We're going to use that formula because we know it's a 3 hour cruise. So the total time upstream plus the total time downstream has to equal 3 hours. So I'm going to take the 15 kilometers that they're going to go, divide it by the speed upstream, x minus 2. And the 15 miles they come back and divide it by x plus 2, speed downstream. And that's going to be 3 hours. Now we get to use our algebra skills. We need to solve for x. Because I've got this really, really ugly equation at this point. Okay? This is really ugly right here. Okay? That's an ugly equation. And we're going to solve it by using our algebra. First thing I'm going to do is I'm going to multiply times x minus 2x plus 2 to get rid of these denominators. I hate fractions. And so what I get is 3 times x minus 2, x plus 2, and I get 15 times x plus 2 and 15 times x minus 2. Okay? So I'm now going to take that information and I'm actually going to expand it. Well, the x plus 2, x minus 2 turns into x squared minus 4 because there's a difference of squares there. And when I multiply that by 3, I'm going to get 3x minus 12. And over here, I've got a plus 30 and a minus 30. Those are going to cancel each other out, and I'm going to get 30x. So I'm going to subtract that and bring it all over here to the left, and I get 3x squared minus 30x minus 12 is equal to 0. Remember, x is the speed of the boat. So if x is the speed of the boat, all we got to do is solve this equation to find how fast the boat has to go, right? And so what we're going to do, we're going to use the quadratic equation. Oh my gosh, I hate this one. So minus b. Well, in this case, it's already a minus, so I'm going to make it a positive number. 30 plus or minus the square root of negative 30 squared, that's 900, minus 4 times a times 3 times c, which is negative 12. Well, that's going to turn out to be a positive number. Thank goodness it's going to be a positive number. 900 plus 12 times 144 divided by 2a. Well, that'd be 9. That'd be 6. So I'm going to get that, put it all together, and what do I get? There's my A, B, and my C. I plug the values in. I work through the whole thing. I'm going to get 900 plus 144, and that's going to be 1044. Take square root of that, and that's about 32.31. And 30 plus 32.31 is 62.31 divided by 6, and I wind up with, oh, it's a plus or a minus, so it's either 62.31 divided by 6, which is 10.39, or 30 minus 32, which would be a negative 2.31 divided by 6, which would be this negative 3.9. Now, wait a second. Can we go negative 3.9 miles per hour? Backing up? Yeah, I get that, but you know what? The boat didn't back up. It's kind of hard to go 15 kilometers downstream if you're backing up. You know what I mean? So we're going to eliminate that negative 3.9. It makes no sense. Real world, not good. But the x equal to 10.39, perfect answer. So we're going to take that and we're going to say, okay, that's 2 decimal places. Hence, the boat journey upstream is 15 divided by 10.39 minus 2, or 1.79 hours. Right? Well, that's an hour and 47 minutes. And the journey back downstream would be that 15 divided by 10.39 plus 2, or 1.21 hours, or an hour and 15 minutes, an hour and 13 minutes. So, work this all out. Boat driver didn't have to do the algebra 2 work, did he? Boat driver gets in the boat, and all he has to do is you go an hour and 47 minutes upstream. Okay? You turn around, you come back, it'll be an hour and 13 minutes. You will have gone 15 miles. Boat driver is happy. He doesn't care anymore. He can measure it by time. Okay? Are there other real world examples? Sure. Resistors that are run in parallel in electronics, parabolic mirrors and satellite dishes, lenses that are used, time and distance problems that you'll see in physics, and some economics problems that you might run into. All of these are examples of real world problems. You're going to see some of these in your practice that you're going to be doing, but I'd also recommend looking out on the internet and see if you can't find some examples of these type of problems. They're fun to work if you work them out correctly, and you can, if they fit into an area that you're wanting to go into, you can start to see, hey, this makes sense how we're going to use this in the future. Even if in your real world experience you don't use algebra 2, you can see how someone must have used algebra 2 to put it together. Because like I said, boat driver's not going to do algebra 2. Someone else has done it already and told him how far he needs to go. Okay? Having said that, don't forget that if you're sending me a message, make certain you tell me you're in pre-cal. Helps me find your records that much quicker, and I can answer your questions easier for you. Otherwise, I will see you when I see you.